This next example is an application that is going to give you some meaning to your variables and your functions. In this case, we have a function for profit. P of xy is going to be maximized, right? We want to maximize profit. That's what makes more sense rather than minimizing profit. So your profit function is given. That needs to be maximized. X stands for how many refrigerators are shipped to store A, and Y is how many refrigerators we ship to store B, that we supply to store B. And so your constraint function is given to be some connection between, some relationship between X and Y, such that you can produce exactly 7,000 refrigerators. And so we needed to understand how to use that to come up with your constraint function, which we referred to as your G of XY function. So I'm going to ask you all to complete number 2 as your quiz for this week. And the quiz question for this week is due. Give me 1 minute and I'll dig this out for you. All right, your quiz question over 7.5 is due on Friday, April 10th by 8 o'clock in the morning. I suggest you get that done Thursday night so you don't have to get up early and do it. So you're going to either print this page out and write directly on it, or you can copy this question on your own sheet of paper and do your work there, and then scan it and submit it to me in ReggieNet in the assignments location. And that is due once again by this Friday at 8 a.m. Number 3 is an example where you have a manager is given $8,000 that he can spend on the development and promotion of a new product. It's estimated that if X thousand dollars is spent on development, Y $1,000 is spent on promotion, then that means your function f of xy tells you how many units of the product could be sold at those two levels for x and y. And we want to maximize that, don't we? We want to maximize the number of units that we sell during a given period of time. And that needs to be subject to a constraint, right? So your constraint equation, subject to. Now, this is where you were told that the manager has $8,000 available. All right, and you were told that X stands for how many $1,000 are spent on development and Y $1,000 on promotion. And so those two numbers, those two quantities together has to equal $8,000. Now, don't make that equal to 8,000, right? Because X and Y are in thousands. So just make it equal to 8. All right, so first up, we find the partial of F with respect to X. We get, I'll show you the steps. We get 50 times 1/2 times x to the negative 1/2 because we subtract 1 times y to the 3/2 because that's a constant right now. The partial with respect to y is going to be 50. This time y is the variable, so times 3/2. X is the constant. And let's go ahead and find the partial of g with respect to x. That's just going to be a 1. Partial of g with respect to y, that's just going to be a 1. And now we come up with our Lagrange multiplier equations. So that's going to say that, I'm going to simplify at the same time here, that is going to say that 25 y to the 3/2 over x to the 1/2 equals lambda times 1. And the second equation will say that, let's see, 75 x to the 1/2, y to the 1/2 equals lambda times 1. Now these are nice because they are already solved for lambda, so I can simply set them equal to each other. One quick note, don't forget that your x plus y equals 8 also needs to be thrown in there to complete your system of equations, okay? All right, but first I'm just going to talk about those first two equations. They're already equal to lambda, and so they are equal to each other. And so that'll say 25 y to the 3/2 over x to the 1/2 equals 75 x to the 1/2 y to the 1/2. Put that over 1 if you like. And now we're going to simplify this until it looks useful. Right now it does not look very pretty. So what could we do to make this better? Well, maybe cross multiply, right? So one direction, I'm going to get 25 y to the 3/2 equals 75 x y to the 1/2. Now I can divide both sides by 25, and that makes it a 3 over here. I'm going to divide both sides by the y to the 1/2 factor, because that's going to give me just y on the left equals 3x. Now that looks so much better. I played around with it a little bit using some techniques I know from algebra, and I ended up getting the equivalent equation that says y equals 3x. That's great. Go back over here to that third equation, which was your constraint. Substitute the 3x right there for the y. You end up getting x plus 3x equals 8, or 4x equals 8, so x equals 2. X equals 2. If x equals 2, what does y have to be? Well, that same constraint equation can tell you what y should be. If x is 2, y's got to be 6. Right? Because I have to make sure that constraint equation is made true. Y has to be 6. So you might want to write a statement here or understand your interpretation in case you're asked to fill in the blanks. On Connect Math, you would say that the manager should spend $2,000 on development. So we'll say spend $2,000 on development. Pay attention to those units too. Sometimes it's easy to miss that. And how much on promotion? $6,000 on promotion. And that's going to maximize sales. Good enough. Now, part B, this is new. Suppose the manager is allotted an extra $1,000 for development and promotion. So instead of $8,000, we're going to give him $9,000. Figure out how the sales is going to change without doing too much work. So instead of using $8,000, I would have x plus y equals 9, right? $9,000. Now I have an extra $1,000. But it says use the Lagrange multiplier, which is your lambda, to figure out how much your sales is going to be affected by this increase in the constraint. So the lambda, remember, is equal either to, I could either use this equation or I could use this equation. Makes no difference which equation I choose to utilize right now. I like the second one. All right, so lambda equals 75 x to the 1/2 y to the 1/2. Great. And don't forget, you just found x and y. Use x equals 2 and use y equals 6 into that equation to get the amount of change. 75 times the square root of 2 times the square root of 6. Work it out. You end up getting something like 259.8, or how about 260? A statement that you would want to make, right? It's all about interpretation here. Well, you would say that if the manager is allotted an extra $1,000, for development and promotion, if that stuff up there, then sales will increase by about 260 units. All right, so that is how the Lagrange multiplier could be used to answer that last part.